Okay, so today we're going to look at recursive formulas. So a recursive formula tells us how to find a term from one or more terms that come before it. So in this case, we need to know the term right before the one we're looking for in order to apply the formula that they give us. So suppose that a sequence is defined as follows. A1, remember that's the first term, equals -1. And then a to the nth term equals -3 times a, which is our initial, n minus 1. So whatever number we're looking for, our term number minus 1, plus 6. And we want to know for n is greater than or equal to 2. Okay, so on this one, we're just going to go through and list the first 4 terms. They're just asking us to apply this. But remember, with this one, I'm not just simply going to plug in 1, 2, 3, 4 for my first 4 terms. So I'll show you since I need to know the term number before it to do this. So A1 is -1. They told us that, right? That was given already. So that's my first number that I can list. The second term, which is going to be 2, there should be a 2 filled in there, forgot to fill it in, equals -3 times A, and it's 2 minus 1, which is 1, right? Remember, that's a little denotation. That's not, it should have probably used a smaller 2 there, but it's not 2 minus 1 like in parentheses up top. It's like the little denotation like this 1 here, okay? So now I know I'm looking for A1. Well, I know A1, that's -1. That's what we just did on the first piece here, right? Or the one they gave us. So I'm going to plug in -1 right here. So you can see I circled it here so you can see it. I circled it again here, or I could even gone up here to the given. And so now I can plug this in. -3 times -1 is 3, because it's a negative times a negative, so it's positive. And then 3 plus 6 is 9. So now I know the second term is 9. So now I'm going to go through and I'm going to find the third term. So -3 times A, the term A, 3 minus 1, right? And then I'm going to add 6 to that. So the term I'm looking for is 2. Well, I just found the second term, that's 9, right? So I'm going to plug 9 in here. So you're finding the term and then you're plugging it in to do that one. So -3 times 9 plus 6. So -3 times 9 is -27 plus 6 is -21. Okay, so each time I need to know that term number in order to apply this formula. So the next one for the fourth term, I'm going to go 4 minus 1. So I'm looking for the third term. Well, we just found the third term. That was -21. So I'm going to plug -21 in here. Sorry, I went a little crooked because I didn't have quite enough room for the negative. So -3 times -21 is positive 63 plus 6 is 57. So this is how to apply a recursive formula when they give it to you. You need to start with, usually it's the first term they give you, and then you work your way forward from there. Okay, so it's a little different than the other formulas when we were just looking at, I can plug in any term number that I want and work out the formula. I actually need to know a term number, the previous term number, in order to find the current one that I'm looking for. So for a formula for recursive sequences uses the previous term, whether it is arithmetic or geometric. If the sequence is arithmetic, then the common difference will be added or subtracted from the previous term. If the sequence is geometric, then the common ratio will be multiplied or divided from the previous term. So those are just basic definitions of arithmetic and geometric. Hopefully that sounds pretty familiar at this point because we've been doing this for a few weeks now. So arithmetic recursive sequence, this is what it looks like. And the basics that you're going to always have there are the text that you can already see. So if you notice they're identical, we're just going to change. For arithmetic, it's a common difference, right? And we add the common difference to the term number -1, okay? Or we multiply the common ratio for geometric for the term number -1, okay? Or the previous term number, I guess is a better way to say that. So if we look at this, I just scooched it up so you can still see the formulas at the top. So we're going to write a recursive formula for each sequence. So for this one, for A1, they're just asking you to identify what is the first term. And then I'm going to need to know what the common difference or the common ratio is. Now in this case, I kind of pushed that a little early. This definitely looks like subtraction to me. That's going a little slower. This one definitely looks like multiplication to me. So common difference, common ratio, you can even see I gave you that clue down at the bottom too, common difference, common ratio. So our common difference, if I subtract, I would have to subtract 6 to go from 11 to 5. I'd have to subtract 6 again to go from positive 5 to negative 1. Because think of the idea, like if you think about a number line, I have 5 positive, then I have to go one more to then get to negative 1. And then to go from negative 1 to negative 7, I'd also have to subtract 6. So the common difference is negative 6. And my first term, well, that's 11, right? That's the first term they gave me. So that's all they're asking you for here is the first term for A1. Now we're going to write a recursive formula for this. So we're going to use our common difference. So I'm going to have negative 6, because that's the common difference we found, plus a to the n minus 1, or the term n minus 1. All right, so now let's look at this one. So this is definitely multiplication. So I have to multiply by, it looks like 10 here, and then I'd have to multiply by 10 again, and then I have to multiply by 10 again. So this one, I'm just confirming when I do this 3 times, I know I'm going to find a pattern. I'm just confirming it's the exact same pattern. So I'm not accidentally looking at the wrong pattern. So I have a common ratio of 10. Since it's multiplication, I'm going to use the geometric formula, which is the common ratio with multiplication. Okay, my first term is 4. That's just the first one they gave me. And so the formula here is going to be r, which is 10, times the previous term, a n minus 1. All right, so that is solving a recursive formula, kind of finding the terms of it, and then writing recursive formulas for both arithmetic and geometric. I hope that helped, and I will see you in the next video.